Okay, I wanted to show you guys this HP 334 Alpha universal counter here. It works-ish. So I've got this Sigent connected to through a T to both this Gold Star, which I did a video on. Just it was a Korean plug, and that's all it really took. Cleaned it up, and works great. So I got this at the 50 kilohertz, just 2 volts peak to peak. So when I turn it, this is off for now, of course, but when I turn this on, you can see this thing's pretty much dead on, you know, and I can crank it to 1. We can go a little faster if we'd like. Better resolution, lower, slower, a little slower, but that's fine. Anyway, this thing's dead nuts on. So we'll go back down to 50. And I'll go to 1. When I turn this on, 2 things are going to happen. One, well, I think I'll get the error 5.2, which is okay because I can clear that. I think that's GPIB settings. I can't recall, which I think is the battery inside. It's probably original and probably needs to be changed. I don't use GPIB anyway, but it would be nice not to have to press the button every time. More concerning is the message I'll get. So let's just try this out here. So yeah, there's our error 5.2. That's fine. I can reset that. OFL, right? So I'm guessing that means overflow. It could mean something else. It's not all the time. It'll come and go. So I'm on A, and I have the manual for this. That's error 1.1. Oh yeah, I didn't like that. OFL. The trigger doesn't seem to matter. Well, if I turn off auto trigger, yeah. AC doesn't matter. It's not a 50 ohm times 10 attenuation. I don't think matters. Maybe it does. Yeah, I'm going to get nothing on that. Now I will get a reading occasionally if we'll just start playing with this. You can see it. I'm going up over here. I'll turn this down just 1, just get a little quicker. So this is very responsive, almost instantaneously. This I'm still getting OFL. I will get a reading on frequency, and I get nice, you know, all the digits and whatnot. This might be the first time it's just OFL the whole time. You know, I've looked this up. I found one thread on it on eevblog, and I have the whole manual somewhere here. It's, I don't know, 100 or so pages. So I've got the counter operation and performance tests. I can't find OFL anywhere in this whole thing. Oh, hey, see, there it goes. So now we got 59. So now it's, and then back. So it seems intermittent. You know, I can't, there's no rhyme or reason to it, which is any troubleshooter will tell you intermittent faults are the worst because you never really know if you fixed it, and when you do, if you think you did, you never really know what did. Give me a hard fault any day. But yeah, you can see it went away, now it's back. Let's just try some settings here. We'll go to frequency, we'll try 10 megahertz. So I'm up to 10 meg on that, or 10,000 kill. I don't think it's something I'm doing wrong. It very well could be. I'm not an expert on this thing. It's got, it's got so many features, which is awesome. I'm using it for the basic purposes, and I have the manual, and I'd like to learn more about it. I think I used to use these way back in the day in the lab. This is probably on amongst our equipment rack. It's just been so long. Let's try B. So we'll go input B. We'll switch over to B. Oh, attenuation off. 11 meg. Where's my trigger? Auto trigger, perhaps? Oh, this might help. I gotta look up that error 1.1. It does not like that. I'm still triggering on 1, and I'm not sure on A, and I'm not sure why. There we go. So 11 meg, 10.99999. I love that long readout. So it might stay here for a while, and then OFL will just, there we go. It heard me. And it comes back, and it goes back, and I don't know. So I may put the question to you guys if you've seen this, if you've heard of it, if you know any information on this. I was going to crack it open anyway to check out that battery, and amongst other things, just to do a general inspection. But, you know, it seems solid. Other than that, I'd really like to use it. Like I said, I love that display, and it's a nice counter. I got it used. I can't remember how much. But these are, at the time, the top of the line, I think, you know, compared to this. But I'm loving this thing, too. It's so responsive. And it doesn't have a mirror error message, which is nice. But, you know, as soon as I change this, that thing switches over, which is nice. Super easy to use. Let's go. There we go. 16. So 16 meg, 16 meg. I think this goes up to 60. Yeah, we'll try 30. Why not? 30. Let's try some resolution here, and we'll go down to the thousandths place. So 30.001, 30.005. 30.009. Yeah, anyway, that OFL message, again, I'm guessing overflow. What else could it be? Yeah, I don't know. But I think I'm going to crack this bad boy open and take a poke around. Maybe something obvious jumps out. I doubt. That OFL sounds like a chip thing, or, you know, maybe some embedded firmware. Hard to tell if a chip's corrupted. You know, for me anyway, I can tell if a cap needs changing, you know, or a resistor. A chip, on the other hand, that gets into the nitty gritty. So anyway, we'll crack it open and see what we see. One quick note on this 5334A. Right on the top of the unit, they give you this, it's laminated kind of operating instructions mini cheat sheet here. And kind of cool. Input specs, power up, kind of basic functions, the display, error messages, see manual. Yeah, thank you. How the inputs work, read levels. If I can zoom in on the bottom here, or focus on the bottom rather. Yeah, kind of cool. Well, HPIB, GPIB, their flavor, I believe. Math and memory. I mean, this thing will do all kinds of stuff, way beyond probably what I'll ever do. But I do remember using these way back in the day. Not to date myself. 20 years ago, I guess, ish. And amongst the rack of all sorts of other equipment, a no-scope and a network analyzer, a spectrum analyzer, we always had a counter in there, and these things are reliable. But again, I got that weird message, OFL. Nothing on here about that, as far as I can tell. Nothing in the manual. So I'm going to get the case off, and we'll see what we see. So another quick discovery I made before I got the case off. So you can see here we got the DVM with no terminals. I thought, well, I don't have that option, right? However, if I flip this around, first thing I noticed is you can see here options, right? So they're circled in. So I've got 020, and if you look at the manual, 020, 100, 1000 volt floating digital multimeter, HP5334A only. I thought, well, where's that? Well, duh, it's right there. So I do have a DMN. It's just on the rear. So that's kind of cool. Yeah, 500 volts max. 1 kilovolt max. So yeah, I can plug in some leads back there and set it, forget it. And then the other option there, you can kind of see 06060. And if I look at that here, 60 rear panel inputs, channel A, B, arming, and C. C for instruments with option 30. So I don't have 30, but I have A, B, and arming. And sure enough, here's our, get back here, you can kind of see arm A, arm B. So yeah, it does have some options, and a DVM, just not in the front. That's kind of cool. Well, I'll take that. So I'll have to try out that functionality there, the DVM, a little later, and see how she behaves. But I don't know how accurate it is. But yeah, we'll check it out for sure. So finding all kinds of fun things on this thing. I haven't got the case open yet. Okay, so we got the top cover off. Just 3 screws, not too bad. And this is a dusty boy. Yeah, so I'll have to blow this thing out, but just taking a look. We have big fat caps here, Sprague. So those are nice. Here's our DVM option. The 2 wires going to the back panel, so that's cool. And there's some adjustments there. Range adjust, low, medium, high, 0 offset. Whole lot of ICs here. Again, really dusty. And I believe this is our battery, BT1. So I'm going to take a look at that. Maybe I can, let's see here. Let's turn this around. Yeah, so right here, I cannot screw this up, right there, you can see BT1, got the zip tie around it. Doesn't look, just dusty. I don't think it's leaking or corroded, but certainly has some dust problems here. This cap here maybe seen better days. C39, could just be the plastic or the seal, but I don't see anything obviously leaking or damaged. It is behaving. It is, other than that message OFL, it seems to be doing okay. Oh man, this stand does not want to cooperate. Anyway, kind of cool. Certainly well built, very well laid out. Love the labels here, very clear sections, dotted line. We got some regulators back here. Here's our, looks like a CR1 full wave rectifier way back there behind this big fat cap. And then this is just for the DVM. Looks like I can just take the whole thing out, which makes sense as an option. Kind of cool. Input switch could probably be cleaned. Can't easily, as far as I can tell, easily get to the front. I bet you I can get the front panel off by itself and maybe get to the front board. Hopefully I don't have to. But I think the first step is, they got these nice RF lines here. They just go right to the front, or from the front. There's a mirror to these BNC jacks in the back. What cable do they use? LM9032. I've never used that. So we can kind of see that there. LM93. I was thinking like RG142 or something. I'll have to look that up. LM9032 USA. So yeah, I'll dust this out, blow this out, and see how hard it is to get to this battery. I think this is just a cover here, zip tie. Maybe if I clip that, the cover will come off and I can take a better look. All kinds of trim pots here for adjustments, and the manual has all kinds of adjustments. So we'll get to that, I believe, but for now, let's clean this up. Okay, so as I was blowing this thing out, whole lot of dust. However, some of the board finish came off. You can see here, see that the top came off, which is sort of coming off in pieces. So I can see here just the thin film of it, and in some other spots right here it's a little bubbly, and it was kind of flapping up and down. So it's just a handheld blower. I don't think it's that strong. I just have 3 settings, so I dialed it back. But yeah, I don't think anything is spilled. I can't tell if that's corrosion there. It kind of looks like it. But again, it's behaving pretty well. So I'll have to take a closer look here, and that cap looks a little sus. I don't know. This one's, I think it's the same model, and that looks okay. Yeah. So time to be super careful, because that laminate here, or whatever you call it, wants to come up in some spots, and I'd rather not have that happen. But I'm going to get to this battery, this black here. It's got a zip tie. I'm hoping that, well, let's just do it now. Where is a cutter? So I can do this without breaking anything or scratching things up. There we go. So there's our zip tie. I'm gonna turn this for you guys. Well, I should go this way, actually. I don't have an overhead camera shot, unfortunately. That would be the easiest, but let's see. There she is. See if I can. Oh, come on, buddy. So, oh no, that does not want to come up. I don't think that's screwed in. Maybe it's a clip. Ooh, that's pretty solid plastic. I don't think that's something I can squeeze and pull. I could be wrong there. Yeah, that's almost on itself. Interesting. Yeah, you can see some of the traces there. The cover, nice and silver there. So I'm gonna have to clean that up, get some alcohol. I don't think the battery leaks, but I could be wrong. So I think I'm gonna have to get the bottom off this and see how that's attached. If the plastic itself is bolted, because I don't want to do too much force here. But that seems like one solid piece. It's not a cover that just comes off simply. Yeah, so I'll have to take a look at that. So let me see if I can figure out how to get this bottom off. We'll flip it over and we'll take a look. Okay, so the bottom cover came out pretty easily. Once again, just 3 screws, which is nice. The feet come out, and I just lost the screw. And my floor is white, so I can't find it. It's there it is. Anyway, 2 of the 3 are the feet, or the rubber bumpers. So it looks okay. So here's the battery, bottom corner here, BT1. Terminals are, yeah, I mean, it's seen better days. I don't know the pin out, but I can try to figure it out. This looks like our ground plane here. So I'll buzz that out. One interesting side note, unfortunately, I'm looking at this big honking manual here, and unlike, say, Tektronix, I cannot find a BOM or a list of parts, which is unfortunate. That Tech 2225 I did has a whole list, which is super nice, and I don't see that in here. I'm sure I can find a part number, probably online, for that battery, and see what the voltage is supposed to be. Also, side note, this is kind of cool. This is for connecting to the HP-IB, which I think is, again, their version of GPIB, General Purpose Input Bus. Check out that computer, HP 85 desktop computer, ROM drawer, 16K memory module, interface card, and then you can talk to the GPIB on the back. Look at that honker, man, old school. Those were the days. So let's see if I can, where's my meter? Let's see if we've got anything on this battery. Anything at all. Let's see here. Oh boy, I'm just dropping everything today. Let's zoom out a little bit. So DC voltage, I'm just going to go to some points here. Minus 2.20-ish. I got 4 terminals here, so there's only so many combinations I can do. But this thing appears to be dead. I've got, no matter which way I go, 0.18 volts, 0.116. Let's drop into 0. Yeah, this thing is, there's nothing on this thing. And the terminals, solid terminals have seen better days. It may be leaking. There's a little, kind of a spot here. The traces are, probably can't see that. Let's see. Again, I need an overhead shot here. I'll put that on my list of things. Where are we? There we go. You can kind of see the oh, why is this not auto-focusing? I lost my touch. Oh well, hopefully you can see that. But you can see this trace here, seen better days. There's kind of a spot behind this pin. I mean, these look okay. The terminals themselves need to be resoldered. So I think that the top plastic part of this is all just one part of it. But yeah, I've got nothing on this. Just, you know, 1/10 of a volt, 2/10 of a volt. So that sucker is dead. I'm hoping I can find one that's the same package. I think I read somewhere that they, obviously not the same original, but replacements that come in the same form fit package, which would be ideal, of course. So I'll take a look at that. Okay, we'll try to get the C39 out. You can see it right under the bar there. Let's try not to screw this up. I don't have a fancy solder sucker yet, electronic one. So we're gonna do the old-fashioned pump and dump. Let's see here. I gotta use my left hand, which I am not a big fan of. I lost my solder. Let's see. That's pretty good. Not as good. Let's see if I can finagle this thing here. 39, there she is. Oh yeah, it's already a little loose. That's not fucking great. Need to turn this up a little bit. Woof. Oh man, she's bulging. Let's see if we can see this. Look at that. I don't think that's supposed to be like that. The bulgy boy. Let's see here. What we read now. So not terrible. 132.4 micro, and it's supposed to be 100. It's 30% out, and then 0.98 ESR, which I think is okay. Let me check my 10 micro at 16 volts, 16 ohms. Oh yeah, we're way under that. Or, well, 100 micro. There we go. 1.6 ohms. We're at 0.98. That's one chart. There's all kinds of charts here. 100 micro at 16 volts. This one says 0.7 ohms. So either way, we're high on resistance, or capacitance, and we are somewhat high on ESR, and I don't think it's supposed to bulge like that. So this one's going to get changed. So I went to clean the terminals, the 4 terminals for this battery here before desoldering it, 1, 2, 3, 4, with some standard isopropyl alcohol. And as you can see, the labeling started coming off. There you go, right on my finger there. So that's not great. I don't think that was the alcohol by itself. I've never seen it do that before. You know, I can do that on another part of the board. I can scrub it pretty well. So I think this battery did leak a little bit there. So I'm going to get it out and clean it up as best I can, and yeah, go from there. So the parts came in. We've got a new battery, a Varta, come on, 3.6 volt, and it's the same, basically the same form fit as the old one. So that's nice. That should slide right in. I also double checked because I didn't need to desolder the terminals. Those are permanently mounted. I did double check, and I do have continuity there, so I didn't do too much damage there, and this should slide in. And also explains why it was zip tied. It was a zip tie holding that thing in. Also got 6 new, 5 here and then 1 here, 100 microfarad capacitors. These are Nichikan. If you'll focus for me. These are pretty nice, and I'll test one here just for fun. See how close we are to 100 micro. The others were, like I said, we're reading 130. You know, plus 30% isn't great. I was more concerned at their shape, and they are, I don't know, 20-something years old. So let's see here. So yeah, 103, not too shabby, low ESR, and let's check out this battery too while we're at it. See what kind of voltage we get on this thing. I don't have any clips connected, but I can make this work. 3.7. Ah, beautiful. All right, we'll take it. So I'm going to go ahead and try to get these all in. Okay, so we've got the battery in. Zoom in and down here. I looked everywhere for my silver Sharpie, and I cannot find it. So I just put a little label on there for the month and the year, 0822. I know as soon as I button this thing up, I'm going to find that silver Sharpie. But for now, I think this will work. Nice and zip tied, nice and tight. I buzzed out the pins on the other side, and they go, I've got continuity where they should. I've got 2 new caps here. Boom, boom. And we've got 4, if we can see, down here. You kind of can't. I got to lower it. But 1, you have to trust me. 2, 3, and then 4. You know, I was also thinking, so I've got this DVM board, excuse me, and it goes to the rear panels. So I got the DVM option in the back there, red and black. And I was thinking, you know, I've got these front panel, they had these dummy caps in there that I popped out. And I've changed binding posts before, these little dummy caps. So why not just put these up front, right? However, to do that, the plastic nut comes off easy enough, but I would have to desolder this. And, you know, this is factory. It looks really nice. It's really well done. I don't particularly want to take off this insulation and then desolder it and then hope I don't screw it up and burn the plastic or whatever and then move them down here, when I could just leave them connected and just buy, you know, kind of an extra an extra long pair of leads and just drape them around the back of the lab or the bench and have those ready. Buttons are still in the front, of course, so operationally it doesn't really change anything. Just I can plug them in the back and forget them. So I'll get this nut on here, get all that tightened up. Hopefully we can get these dummy caps back on the front. And then we'll power this thing up and maybe something is fixed. Okay, so we've got her plugged in to my ISO DIMM. I got it on limit just to be certain here. So let me turn the output power on. This is my first time turning it on. I may not like limit. In fact, I'm going to risk it. Go to bypass and see what happens here. So there's our usual error, but it's the first time turning it on, so that might be okay. Let me move this out of the way and get a little dimmer here. Let's try an input. So we'll do, nope. So OFL is back. Frequency A. There goes my leads. Let's see if we can get that on camera. That fell earlier when I was not in the room. Yeah, so the magnet on the side here came unglued from the back of that. Maybe I put too much weight on it. And it just fell off. And it just did it again. So that's frustrating. Everything's going wrong today. Oh man, hold on a second. Let's see. Oh, I'm at 1 hertz. Derp. I thought I was at 1 kilohertz. My mistake. Let's try this again. 1 kilohertz. I don't know that's going to matter. No. Auto trigger, sure. I don't know. Yeah, it never likes when I do that. Yeah, so we still got OFL. That's frustrating. I was hoping that battery might fix it. Apparently not. Let's cycle some power here. I'll give it a second or two. So no error 5.2 that time. That seems good, but the OFL is still there. That's the one I really wanted to fix. I can live with the 5.2. It's just hit and reset. See, it's intermittent. I don't get it. Is it a trigger thing? Is it me? That's trigger cranked all the way counterclockwise. That does not seem to particularly matter. Let's try, I don't know, 37 kilohertz. Just to pick a number here. When it works, it's, I mean, 4 digits in. That's pretty good. OFL. Yeah, man, that is frustrating. I don't know what that could be. So a quick aside, I've turned this on and off. There's no input right now. But I've cycled power on this, I don't know, a half dozen times. And it has not come up with that error 5.2 on the self-test. So I think that battery may have fixed that, which kind of makes sense. No battery to retain the settings. It tries to find its GPIB address. Throws an error every time it powers on. Says, I don't know what I'm doing. Now, despite I didn't program one, but at least it can retain whatever it needs to. Power on. Say, yeah, that's what it is. Address 3, pass. So, again, of the two problems, I would have rather fixed the OFL, because that's persistent and intermittent and super annoying. But you take small victories where you can, and I'll take this one for now. Means I don't have to push the reset button every damn time I turn this thing on. Yeah, so that's something. So I've got the manual out. I was going to check out this DVM portion here. There's two sections with regard to the DVM, options 20 and 50. So the first, performance test. So place a jumper across the inputs of the DVM to short them together, which I did. I used just 20 gauge bare copper wire, so let's jumper it in the back. Reinitialize the
5334, excuse me. Okay. Function DVM. And what's it say? Observe, the front panel displays 0 volts, excuse me, plus or minus 8 millivolts. So yeah, I'm under that. 10 to the negative 6th. I'm way under that, I believe. So that works. And then connect the rear panel gate out signal to the DVM inputs. So I gotta find that. Let's turn this off real quick. Let me take off this jumper. Where are you? So yeah, there was my little jumper wire. Gate out. Where are you? Gate out. Ah, there she is. And I'm gonna need my BNC. Whoops. BNC to banana plug. My bag o adapters here. I haven't put up any bins yet. I should get some more official storage. So we've got our DMM to BNC. So let's screw these in. We'll go gate out. Come on. Gate out to DMM. So that's connected in the back. Whoops, we'll turn this on. I do like that it's passing as far as initializing, so I think the battery did fix that problem. So, DVM function. The front panel displays a measurement greater than 50 millivolts. So yeah, I'm at 67.2 minus. Shouldn't matter, but let's flip this around just for posterity. Yeah, there we go. 67 millivolts. And I want a measurement greater than 50 millivolts. Okay, good. So those are the only two in the performance tests, and they both seem okay. And then there's another whole section. It's 4-31. Perhaps? Or 36? No, I can't remember. There we go. Section 443, DVM accuracy test. So I'm going to need, they call for a Fluke standard 343A. I do not have that. I do have a power supply though, so we'll just go with that. Okay, so power off. Let's undo this, this. Where are my leads? So let me zoom out here so you can see that as well. Trying to get this all straightened out here. Sorry. Okay. Leads. So we're good there. Let's go. Findings. Positive. Negative. So they want voltage 4 volts. See if I can dial this in here. I'm gonna blow past it. Yep, I knew it. So I love these 10-turn pots, but you got to be really patient with them because they're easy to blow past what you were dialing in. So now it's going to, ooh, I think this thing might be messed up. I'm going clockwise and I'm losing It's getting lower. I just checked this out too. Maybe I didn't do a good job. So we'll go 4. Stay. Okay, so 4 volts. Reinitialize. Pass. Wait a minute. Place a jumper across input. I just did that. I think they've got these mixed up. So I just did that part. Verify the counter reads 4 plus or minus 0.01 volts. So I'm pretty close. I think I can live with that. I'm, what, 4 1/1000ths of a volt low. Because plus or minus 0.01 would be 399. Switch the polarity. Okay, we'll try that. And counter display is minus 4 volts, plus or minus 0.01 volts. So yeah, I'm 3 1/1000ths low. But again, I think I can live with that, to be honest. The next step is a 40 volt, which I don't have that output. I don't think I have that on me. And then a 400 volt, and I know I don't have that available, not DC. Not AC for that matter. So, and that's it. So what's confusing to me is, as far as I can tell, there's no adjustments in here. And if you look at the board, I've got 0 offset, low, medium, high. There's a couple other pots there. So I don't know if that's a whole other manual. You think it'd be included in this? I'm a little hesitant to go ahead and start tweaking this because I don't know of the range, low, medium, high, you know, is 4 volts, is that the low range? I'm guessing so because they have you test 440 and 400. Heck with it. Let's just see. Let's screw this up. Let's see if I can screw this up. I'm almost certain I can. So let me go back to positive just for posterity's sake. And let's, also for posterity's sake, I think I did this before, but I'll hook up my DVM just for a second reading, if you will. Let's see here, if I can loop these around without... Ah, come on. So that's 3992, 3986. So let's see, I'm going to tweak this low, range adjust low. This may not do anything. It may do a good thing. It may do a bad thing. I don't know. Yeah, it's not doing anything. I'm not going too far because I don't want to mess with this. And there's no way to get it back to where it was. So I'm going to live with this. I Googled and I looked for something with this board specifically, the DVM option board, and all I get is this manual. And as far as I can tell, unless I missed it, which I guess is possible, but there's only a couple mentions of the DVM option in the table of contents. There's how to use the dang thing. Let's see, 3-26. Yeah, it just says DVM key selects voltage mode, which provides DC voltage measurements of signals received through the option 20. The DVM is fully floating and auto-ranging. Gate time is eternally set to 100 milliseconds when voltage mode is enabled. Gate time entry, auto-trig, and external arm select are automatically disabled. That's it. And then there's there's nothing in operation and programming beyond that, as far as I can tell. There's section 4-24. That's the performance test that I did. That's the jumper that things together. And then there is section 4-43, DVM accuracy test, which is this test. And that's it. I don't see anything as far as adjustments or cal. So I've got all these pots on the board, and I don't know how to use them or which ones to tweak. And because of that, I don't want to do that. And this seems pretty accurate. I've got 4 volts, 3992, 3986. I can live with that. So I think what I'm going to do is call this good, sort of good. I still get the OFL, I believe. Let's just confirm that. Let's go back to frequency. Let me turn on my DVM, or excuse me, my SigGen. We'll hook this up. Let that bad boy boot up. Where's my... So we'll go, I don't know, we'll say 2 volts peak to peak, and we'll say 15 kilohertz on. So those are 15. No OFL yet. Ha! I knew if I say it, I would do it. I knew it! So again, I don't know if that's overflow or oscillator something loop. I think I saw that somewhere, but I cannot find anything on this. So if you know anything about this, if you have a lead, a link, a manual, tips, advice, experience, I would certainly be interested to hear it. I've never seen OFL before. I can't find anything on it. It's not the end of the world. It's just kind of annoying. I have another frequency counter that I can use. And I can still use the DVM here for voltage measurements if I wanted to. I bought some extra long leads for the back, which I'll loop around and I'll have them available. I may still buy a dedicated DVM, bench DVM, but you know, between the meter, the handheld and this, that should work. Let's try Let's go big. 15 megahertz. See if that makes a difference. Yeah, so attenuation times 10. That drops the signal, but that's okay. Let's crank, let's go 15.5. I mean, that seems pretty good. OFL less now? I don't have a metric or data, but it seems I've seen it once briefly. So maybe it needed time to cool off. I don't know. Super weird. But anyway, I'm going to end the video. Thanks for watching. If you know anything about the OFL, there it is. Let me know in the comments. If you liked it, maybe like it. That'd be cool. And subscribe. I've got more videos coming. And again, yeah, thanks for watching.